photon mathematically. So, let's look inside. So using basic physics, joining the standard kinetic energy equation with the photon energy equation, or Einstein's energy equation, it gave me this charge, and these values here. So at two different frequencies, at the frequency of 10 hertz, 10 hertz, I get a very small charge of 1.47 times 10 to the negative 50 coulombs. Again, you'll have to notice that the combination of the two energy equations, MQ is mass at the quantum scale, and again, you're going to have to get outside of the idea that coulombs and kilograms are two completely separate things, because I don't think we are anymore. So in this case, this gives me a very small mass, which is a charge at the quantum scale, and at a different frequency, at 10 to the power of 24 hertz, I get a larger charge of 1.47 times 10 to the negative 26. If you flip the screen. Sorry. So passing that through my mass transform equation, I get the celestial mass of what those charges would be. The first one is extremely small, which is 1.1 times 10 to the negative 19 kilograms. And the other one is 1.79 times 10 to the power of 20 kilograms, which is a very large asteroid, even a small planetoid. So the range of these masses actually fit into what we find in the asteroid belt. So I think asteroids are photons. It's pretty simple. Next screen, please. Now, here's I just love the whole thing of photons. As you can see, that in the asteroid belt we have lots of photons. So the asteroid belt in this framework is actually a reservoir of photons, and it actually depicts. If you think about Einstein's energy equation of E equals mc squared, I'm not saying it's correct or wrong, or correct or right, but if you were to think that mass is energy, well, the more mass we have orbiting the asteroid belt would depict the energy level of the solar system. And this is in line with Bohr's theory of energy levels. So essentially, as an atom absorbs more energy through photons, the orbital levels, or the orbital radius of the electrons would flip over to a lower energy level, which would be a higher energy orbit, and it would absorb that photon. And then in the reverse, when it settles back down to its natural state, it would release a photon or photons to go back to its natural state. So you have an excited electron, an excited atom absorbing energy in the form of photons, and you have an atom going from an excited state to its natural state, releasing photons. And the next screen would depict something in that fashion. Essentially, Jupiter plays a key role in this theory. If Jupiter were to change its orbit for whatever reason, its orbit would change slightly, become more elliptical, or reduce in radius. It actually would pick up, based on its own gravity field, a bunch of asteroids that fling into space, and this classifies as a release of photons. Again, I'm going off without too much evidence here. But this would fall in line with the absorption and release of photons within the solar system model. Next screen, please. So, if Jupiter or a gas giant, because it reduces in its radius, its orbital radius, would pick up these asteroids and fling them into space due solely because of its gravity, these asteroids would travel in space either as groups or a single asteroid. And they would be traveling through space. It's called in a wave-like pattern due to the rotational velocity. If they're traveling as a group, they wouldn't be traveling in a straight linear fashion. Their gravitational attraction and repulsion between each other would also create a dynamic between them as they rotate. And the centrifugal forces induced on each other. So as they approach, they don't collide. They circle and they go further apart. So as they're traveling, they're actually going like this, based on their relationship with each other. And if they do collide, and they would just rip down. They keep on going. The key here is to see it from a higher perspective in regards to how matter itself actually can possibly form a wave-like pattern as it travels through space. So the greater the mass charge, the higher the frequency. This is what I've calculated. When dispersed, the collective charge is less, reducing the magnetic and electric field strength. So when they're further apart, the field and the electric and magnetic field strength is lower. When they're closer together, the charge is greater, increasing the magnetic and electric field strength. So as they get closer together, their combined mass would actually give it more of a higher electric field strength and magnetic field strength. Am I flipping? Now, there's a lot of speculation in this theory, besides some of the calculations that I published, the mapping between planetoids and quantum objects within the framework. This is one of the speculations, which I think is pretty correct. If the square root of the speed of light is 17,315 meters per second, and that's the speed of asteroids in the asteroid belt, the reverse would be the squaring of the speed of light, and that would be 9 times 10 to the power of 16 meters per second. This would constitute basically the speed of light at the quantum scale. So if you grab a star that produces light, accelerate it to the speed of light, it would essentially become a quantum particle of some sort. Its emitted rays of light, its photons themselves, would also emit at a different velocity because the time scale is faster at the quantum scale, and this is the velocity that we would travel at. The cool thing about this is, at this velocity, you can travel to Alpha Centauri in 0.46 seconds. The communication applications, if this was correct and we were able to harness it, is mind-boggling, and I speculate that maybe this is why we haven't received any intelligent communication, because we're not using our technology. Next. All right. Now, I'm just going to go on to a couple of arguments that I've encountered to do with this model. And the first one is to do with the positioning of an atom. Well, if you accelerate a star system somehow to the speed of light and beyond, why are atoms stationary? Why is it part of this piece of wood, not floating off into space? It's because as you're accelerating a system that is spiral, or that's rotating, it would actually, as it approaches the speed of light, convert all of its linear velocity, however we're accelerating the system, into complete rotational velocity. So we know that electrons travel near the speed of light, so a Jupiter is traveling about 13,373 meters per second, roughly, and to travel at 99% the speed of light, that velocity would also have to increase rotationally. So the end result is that all linear velocity transfers into rotational velocity, and the atom is formed at x, y, and z, and it's stationary. Next screen. The biggest one is the shape of the atom. I'm not going to go into too much talk about how electrons travel as wave patterns within the atom. They do. This theory doesn't contradict that at all. The only difference is that in this theory, which is the equation I didn't show you, which is the time dilation equation, time increases. And at the quantum scale, you're increasing by a factor of, you're increasing by a factor of 9 times 10 to the power of 26 for 1 of our seconds. So it's relative. And that comes from the time dilation equation that I calculated. So essentially for 1 of our seconds, if you were to look at an atom, 2.9 times 10 to the power of 19 years are passing within that 1 second. So you are seeing all the events that are happening in 2.9 times 10 to the power of 19 years. It's an enormous number within 1 second of our frame of reference. So to challenge a scientist, especially a cosmological scientist or an astrophysicist, to conclusively tell me that the flat orbits of our planets will remain flat over that period of time is, he can't say that conclusively. That's an enormous number to say it's conclusively. So external forces could change the orbits, make them more incline them more. Also, to see 2.9 times 10 to the power of 19 years in 1 second, you can't experience any of the orbital tracks of these electrons. It's all over. And because electrons have charge, they form magnetic shields or fields.